all of the angles in radians, are just fractional slices of pi. But when we think about pi, we're going to think about 1,000. Because pi is how much in the circle? 1/2. And so if pi is 1/2 of the circle, right? If pi is 180 degrees, it only makes sense for half of this to be what degrees? 90, right? And if that's a half, then it would only make sense for 1/4 of pi, or pi over 4, or all the pi over 4s to correspond to what angle? 1/4. This is, remember, calzone. 1/2 of the calzone is 90. What's 1/4 of the calzone? 45. It only makes sense for 1/4 to be a 45. Or to be a 45-degree reference angle as you go around the triangle. Now hold on, it gets a little bit harder, but if we were to take 180, 1 pi, right? Pi over 3. Well, what's 1/3 of 180, guys? 60. Oh, it's a 60-degree triangle. So every pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, all of them are going to be 60-degree angles. It only makes sense for pi over 6, 1/6 of 180, to be what kind of reference angle? Yeah, 30. 1/6 of 180. Thanks, Abby. 1/6 of 180 only makes sense for it to be a 30-degree. Now, we have to go ahead and attach in our brains, if it's a 30, a 45, a 60, what kinds of ratios does it have? X's and Y's, sines and cosines, and we'll get back to that in a second. But let's go ahead and go to our notes first. Blue sticks are coming, so if you guys want, well, we haven't added any new notes yet, but when we do, you can, if you want to put your patty paper in, you can pass the blue stick around as soon as we get a brand new one. You'll leave space and then just continue notes below. But every angle in the unit circle, one way of thinking about it, and I will show you at least two main ways of thinking about the unit circle. One of them is built on triangles from geometry, 30/60s and 45s. 30/60 and 45/45s. So any angle that we come to, whether, what would you guys approximate this one is? Pi over 3, pi over 4, pi over 6?
Pi over 3.
Yeah, I would assume it's a pi over 3, because it looks like a third, right? So then we have to think about, okay, if pi over 3, I'll start with Thomas. Actually, if you want to use it, and then we'll just, if you don't want to use it, just keep it past me. This looks like a pi over 3. With a pi over 3 angle, I could make a right triangle by thinking about the x, the adjacent, the y, the opposite, and the r, the radius, or the hypotenuse. I can think of every point, every ordered pair on the unit circle as a triangle, or every triangle as getting me the ordered pair. Long story short, an equation of a normal circle is x squared plus y squared is equal to r squared. But what's special about the unit circle? What is r for a unit circle?
1.
Yeah, I mentioned it briefly yesterday. Some of you might not have remembered, and that's okay. But r for a unit circle is 1. So x squared plus y squared equals 1, which means every single hypotenuse, every single terminal side of an angle that you're going to show is going to equal 1. Coordinate pairs, or sorry, points for angle measures, the x's and the y's correspond to, or relate to, well, they correspond to adjacents and opposites, which means they're going to relate to trigonometric ratios. And that's the point of the unit circle. If I can spell trigonometric. There we go. And what are trigonometric ratios? What am I talking about? Give me some trig. Tangent is a trig function. Sine is a trig function. Cosine. What else?
Secant.
Secant. What else?
Cotangent.
Cotangent, and then I heard the other one cosecant, right?
Oh.
So it's sine, tangent, secant, and all their cos. Have you guys thought about that one?
What?
Sine, cosine, secant, cosecant, tangent, cotangent. It's all of sine, tangent, and secant, and they're co-functions. They're cos. Cosine, cotangent, cosecant. HPrecalc. Oh, we already taught you that?
Yeah.
What? Sokotoa? What's that?
HPrecalc? That's no fun. That used to be mine. Oh well. Sokotoa and HPrecalc. Anyway.
What's that? We were in Mr. Park last week.
Someone just said HPrecalc. Mr. Shaker.
You said it really fast.
He stole it
was
from
like a
me.
joke.
HPrecalc. We'll get there in a second. Keep going. Okay. Keep going. We're not doing HPrecalc right now. Yes, it's cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. It's just like SOHCAHTOA, but you're taking all of the 1/overs and you're flipping all of the ratios. Cho, sha, cow, C-A-O. Cho. Anyway, coming back. Yesterday we got down our pi over 6, pi over 4, pi over 3 triangles. We didn't go around the rest of the unit circle. We briefly talked about it, but not enough to really make it stick. But first of all, kiddos, where did I get the root 3 over 2 and 1 over 2? And the root 2 over 2, root 2 over 2, and the 1 over 2 and root 3 over 2. All of this came from geometry. Triangles. In geometry you learned, hopefully across from the 30 is the 1, across from the 90 is the 2, across from the 60 is the root 3. 1, 2, root 3, if you did Pythagorean, 1 squared plus root 3 squared is 2 squared. That's called one of the Pythagorean triples. You also hopefully learned the ratios for 45-45. Doesn't mean you remember them well, but 45-45 isosceles, which means the ratio could be x and root 2x, or 1, 1 and root 2. If you're just thinking about the proportions. Ryan, here we go. Jonathan, here we go. But in a unit circle, the radius, the hypotenuse, which is the radius, cannot be equal to 2 or to root 2, so then we can just divide everybody by the hypotenuse. So divide everybody by 2 in the 30-60 triangles. Divide everybody by root 2 in the 45-45s. And so you could go all the way back to geometry every time. You could even just draw the triangle and say, whatever, opposite over hypotenuse, sine will be 1/2. Adjacent over hypotenuse, root 3 over 2. Tangent, opposite over adjacent. You could go all the way back to the triangles, even before dividing everything, to scale it back. And you could do the trig that way also. So I guess there are 3 ways. One way is going all the way back to the 1, 2, root 3 and using the adjacent, the opposite, the hypotenuse for whichever angle you're doing. Or you could get down, memorized, or maybe just understanding the patterns of the x's and the y's that correspond to each of the different angle measures. So kiddos, I want you to go back to, this is a 30-degree triangle, a pi over 6, right? Which one is which, cosine or sine? Go back to the triangle. What would sine be, SOHCAHTOA? Of a 30-60. Opposite over hypotenuse, so sine has to be 1/2. So which coordinate is that over here? The x or the y? So every single time you see a coordinate, the sign of the value is going to be the y. And look, cosine, isn't that adjacent over hypotenuse? Root 3 over 2, and you could even do root 3 over 2 over 2 over 2, but root 3 adjacent over hypotenuse, root 3 over 2. That's the same thing as the horizontal measure, or the x. There's cosine of pi over 6. Now, when you're thinking about the unit circle, and what sine or cosine can equal, you have the following 5 options. 0, 1/2, root 2 over 2, root 3 over 2, and 1. Those are your options, positive or negative, for sine or cosine. What's the smallest of those 5 numbers? 0. Yeah, it's that easy. 0. What's the next one in order? 1 over 2 is the next one. Or you can think of, if it helps, root 1 would be lower than root 2. And if it helps, you could even think of this one as root 0 over 2. And if it helps, you can even think about this one as root 4 over 2. I have them in order. 0 would go first, 1/2 would go second. These ones I can't simplify, so I leave them. This one would be 2 over 2, which is 1. I have them in order. So for some of you really visual people, it's going to make the unit circle a lot easier if you think about this as being the smallest. That one's over a little, over, well, a little bit more, but we could say over in the middle. So we have over a little, over a middle, or in the middle, over a lot, and then all the way. Why am I saying that? For visual people, if you can get down the angles, thinking about the fractional pieces, 1/6, 5/6 is 1/6 away from pi, 7/6 is 1/6 more than pi, 11/6 is 1/6 back from 2 pi. 5 pi over 3 is 1 and 2 pi over 3, so 1 and 1, 2 pi over 3. or it's 1 pi over 3 away from 2 pi away from 6 pi over 3. If you can think in fractions, then you can, whenever you get a placement in the unit circle, you can say over a lot, but not all the way. So what would that be? Over a lot would be root 3 over 2. Up a little, 1/2. Over middle, over 2 over 2, up middle, or over half, up half, in the sense of all of our ratios. He's in the middle of 1/2 and root 3 over 2. He's in the middle of 1/2 and root 3 over 2. 45, 45, they're always the same. It's always root 2 over 2, root 2 over 2. So over part way, up part way, there's that one. But then we have over a little, 1/2, up a lot. Whenever I'm trying to keep track of the root 3 over 2 and the 1/2, I think visually as far as over a little, up a lot. Sorry, over a lot, up a little, or over a little, up a lot. Now, that's only for visual people. For non-visual people, you're like, you just said a lot of words and I'm not tracking. Okay, so you need a way to memorize. You need a way to memorize. So first of all, visual people. If the over a little, up a lot makes sense, let's just keep going to 2 pi over 3, and then the non-visual people, I'll help you get to quadrant 3. Visual people, help me out to get to 2 pi over 3. Where am I going? Over a little or a lot? A little, which means 1/2, but what direction?
Negative.
Negative. Good. So I'm going left a little and up positive, a lot. Which one's that? Root 3 over 2. Okay, for 45, 45. Over halfway, up halfway. Which one's the one that's halfway in between? So that was left, which is a negative, and up, which is a positive. Okay, for 5 pi over 6, I'm going over a lot to the left, and then up a little. So it's going to be the negative root 3 over 2 one, and positive 1/2. And then I'm going over all the way up, so negative 1, and up, not at all, 0. Okay, non-visual people. First of all, if I can get you to memorize the first quadrant, try thinking symmetry. And if that's too hard because it's too visual for you, meaning if you have a 30 degree here, then it will match the ratios on the other side 30 degrees, it'll match the ratios down here 30 degrees, it'll match the ratios down here, wherever you can fit a congruent triangle. These ratios will be the exact same, just the signs will change. Just the signs will change. If you're going left, the x needs to be a negative. Going up, actually in the second quadrant, what are all the x's going to be? Negative. And what are all the y's going to be? Positive. So for all the points in the second quadrant, we have negatives and then positives. In the first quadrant, we have positives and positives. In the third quadrant, negative, negative. And in the fourth quadrant,
Positive, negative.
positive, negative. When we get to the ratios, the trig ratios, maybe we'll talk about all students take calculus. Have you guys ever heard that one? Does Mr. Trey not teach that? Oh, yeah. He does. Did Mr. Park teach it? No? Okay. We'll get back to that in a second when we talk about the ratios. But first, Mr. Crawford is the one who first started teaching that, so Mr. Trey.
All students take calculus, what?
We'll talk about that in a second. Hold on. Let it go. Okay, come back. I'll let you know what that means in a second. It's a acronym. So the A and the S and the T and the C is a way of remembering which trig ratios are positive in which quadrants. So it's not saying that you all have to take calculus. It's saying all students take calculus. A and S and T and C let you know who's positive where. We'll get back to it. Non-visual people, ready? When you look at the angles, a thing to memorize, if going over a lot and up a little, if that isn't visually helpful, if doing symmetry with the triangles, once again, visually that's not helpful, then just say, well, okay, the angle has an over 6. If the angle has an over 6, that's always 1/6 of 180, a 30 degree. Over 6, that's a 30 degree. Over 6, that's a 30 degree. Over 6, that's a 30 degree. All the 30 degrees are going to have the exact same ratios coming from this triangle. You can just memorize. You don't have to understand the symmetry. You don't have to understand the little and the lot. You can say, hey, it's a 30 degree. Okay, 30 degree, cool. The x is going to be, here he is, root 3 over 2. All right. The y is going to be, there he is, 1/2. Except, what are my signs? I'm in the third quadrant. Hopefully we can all graph points, so negative and negative. Go find the other over 6. Who's this guy gonna be? Well, he's still that triangle, he's just kind of been flipped around, but still I'm gonna use, what's the x, what's the horizontal side? 3 over 2. And what's the vertical side of the 30/60? 1/2. But I'm in the 4th quadrant, so I need a positive and a, we can memorize that. I'm trying to show you there are patterns in the unit circle. An over 4, anytime you have an over 4, 1/4 of 180 is always 45. I'm going to have a 45-45 triangle. And the 45-45, I could put 1 over root 2, but it's not rationalized. In calculus, that'd be okay. In pre-cal, we better still follow the traditional math rules you guys have learned about rationalizing. So every over 4 is always going to have a root 2 over 2. Oh, but we're in the 3rd quadrant, so what signs? Got it. Go find another over 4. There it is. Root 2 over 2. Root 2 over 2. Except positive, negative. So I need negative. Either way, I need negative. So who's the last guy? Over 3. What's 1/3 of 180? 60. So it's going to be a 60-30. Same thing as this guy, but flipped on n. So now, what's my horizontal? And what's my vertical?
3 over 2.
It all comes back to geometry one way or another. And whether you memorize better visually, finding patterns, or whether you memorize better just memorizing. Joseph, you're distracting Ryan a little bit, so let's go ahead and try to focus. What am I missing? Who's this guy?
-1.
Oh yeah, because the outermost you can go is always a 1, and it's just the point 0, -1.
Whoops.
Okay. So, long story short, the unit circle is now complete. It only talks about the angles that have something to do with, or are multiples of, I should put it that way, 30, 45, 60. And in doing so, we also get the 90s, the 180s, 270s, 360s, which are really just multiples of 90. So in some ways you could think about it as multiples of 30, 45, 60, and 90. But technically, 30 times 3 is 90. It gets a little confusing right about there. Now, I'm going to go through a few different ways of doing unit circle as we start solving with it. But first of all, before we start solving, we've already talked about how the sign will always be the y. For the unit circle, some angle in the unit circle, forming a triangle, you can always say, since the hypotenuse is 1, that the x over 1, the adjacent over hypotenuse, the x is always going to be the cosine of the angle value. The y, opposite over hypotenuse, will always be the sine of the value. And if you can, if it helps you, if you can draw the triangle for a certain angle, you could actually keep going and say, well, tangent is y over x, or opposite over adjacent. Cosecant, you flip the y, or you flip the sine. Secant, you flip the cosine. Cotangent, you flip the tangent. And guys, this table is just saying if you have an xy point, like we just wrote down for all of those angles in the unit circle, this is how you find all 6 of the trig functions. Sine and its cofunction, cosine. Tangent and its cofunction, cotangent. Secant and its cofunction, cosine. Or you could say sine and his reciprocal, cosecant. Cosine and his reciprocal, secant. Tangent, his reciprocal. Okay. So, if you were just looking at the x and y, this is what you would need to remember. But thankfully, especially for us visual ones, we don't have to just look at the x, y. We can see in the x, y a triangle, which takes us back to the days of HPrecalc and HPrecalc. So even though we are going to talk about HPrecalc and HPrecalc at a future time, because technically you don't have to use a triangle. You could just use the point and use these formulas. But for those visual ones who are like, ugh, I like just going back to HPrecalc or HPrecalc and taking the point and making a triangle, just remember, when you go, we can think of our x as our a, right? We can think of our y as our o, or our opposite. And we can think about our 1 as our hypotenuse. True? So then this one is referring to sine of, they put t, I would technically usually put a theta. We'll go ahead and keep t for right now, that's just how they label the angle. This one is talking about cosine equals adjacent over hypotenuse. Tangent of t is equal to opposite over hypotenuse. Those of you guys that took Mr. Che last year, how's the other one go? Cho. Oh, that's
Opposite
an
over
A, sorry.
adjacent, sorry.
There you go. Sorry about that. Cho HPrecalc. Cho is cosecant, which would be hypotenuse over opposite because you flip the sign. This would be secant, which you flip the cosine, and this would be cotangent. You flip the tangent. So Pitoa and Cho HPrecalc. And just quick things to pull out from these formulas. Number 1, these 4 functions, secant and tangent, cosecant and cotangent, all have denominators, which means sometimes they will be undefined. Secant and tangent both have the same denominator of x. So whenever you divide by 0, secant and tangent will be undefined when the x is 0. And that's going to happen at, well, wait a minute, when x is 0, that means you're not going right or left, right? What angles are you at?
Up and down.
Up and down, hence pi over 2, the half pies, because it's only a half of a calzone, half of a half circle. And then down here also, that'd be 1.5. So 3 pi over 2, pi over 2, same thing as at 90 and 270. That's when secant and tangent are going to be undefined, which should naturally happen because x would be 0, you plug in and be undefined. They're just, you would say D and E, because they were asking for those. And they give you pi over 2 or 3 pi over 2. Cosecant and cotangent, their denominators are different. So this time it's going to be when the y equals 0, when you haven't gone up or down, you've only gone right or left, which is going to happen at 0. Radians and pi radians, which is the same thing as 0 degrees. I guess we could say 2 pi also, huh? 0 pi, 2 pi, 3 pi, 4 pi, all of the pi's. Should be 0, 180. I'll just put a dot, dot, dot. Technically, I'll take off the 2 pi. It's for the angles and any of their coterminal angles. For their angles and any of their coterminal angles. These are the placements in the unit circle. So if they were to ask you for cosecant or cotangent at any of those angles, you just have to say D. There is no number answer, no numeric answer at all. Now, our goal with the unit circle is to be able to do it quickly. Okay? Our goal is to be able to do it quickly. I think it's going to take some time to do so. Today we're covering and showing how to find some of the different ratios, etc., and doing some practice with it. But before I get to practicing with the unit circle, let's cover one more page of notes. So I'd rather cover this page first and then be able to spend the rest of class on finding different unit circle values. And while we're talking about unit circle, you guys were supposed to learn it last year. You want me to do a page with class, see if you can see it? Yeah.
No, I mean, we're done.
Oh, you're done with the glue stick. Thank you. I'll have it on my desk if someone needs it a little bit later. You guys covered unit circle last year. Why am I not just being like, okay, go memorize it again, however you did last year, let's go.
So there's a few more things.
Because we
Well,
have to
there are a few more
understand.
things, but also, Eileen,
Oh,
how important is the unit circle in Calc AB?
oh my goodness,
How about BC?
very.
Now, is it like the big idea that we learn in calc?
What?
Is it like one of the big ideas that we learn in calculus?
Quite.
Well, we use it, right? So here's a long story short in a problem in calc. Actually, Calc AB is trying to think about sweatshirts. They haven't come to any agreement. And that's why it hasn't been made. We should just do the WAC one from last year. They don't have time to think about it. But, long story short, they could be faced with a calculus problem where they have to do all this calculus, get to the very end, and to finish the answer and actually be able to match it to the multiple choice answer, they have to plug in an angle to a trig and solve. They could have done the entire problem right, gotten to the very final step, not known their unit circle, and missed the whole thing. Guess how often that happens? More than you would want to know. In their forever cards, aka in their formulas that they have to memorize and keep memorized the entire year up to the AP test. Guess what the very first card has? The unit circle. Why? Because you gotta know it. They're going to expect you to be able to do mental math with it, and if you can't without a calculator, you're going to be in some pretty big trouble. Meaning, the problems that you do know how to do that aren't tricking you out, you still can't get an answer to because you don't even know the basics. One of the calculus AB sweatshirt ideas was calculus. It's the algebra that kills you. What that means is the ideas of calculus aren't, they're complicated, but they're not impossible. But ironically, it's the algebra. Can you simplify complex fractions? Can you factor in FOIL? Can you do the unit circle, which is actually trig? It's the little things that kill you if you understand the big things. Anyway, all that to say, let's focus on one of those little things, which is a big thing in pre-cal and in algebra too. The unit circle, you gotta get it down in a way that you will remember. In a way that you will remember, not just know for the test and then forget. A few things really quickly about sine and cosine. As we're going down the unit circle, we've talked about how the most you can go out or up, the highest value is 1. Do you guys know what the lowest value would be? Close, 1, but in the negative direction. So the range for sine and cosine both, sine of any sort of angle value, which we can call it t for right now, is going to be between 1 and negative 1. Cosine is going to be between 1 and negative 1 as well. One of those weird functions that really can't equal very much. All the different sine values and cosine values, to all the infinite number of angles that could show up in the unit circle. Or in any circle, I shouldn't just say the unit circle. Sine and cosine will always only be in between negative 1 and 1. Also, sine and cosine, their entire cycle will repeat every 2 pi. The entire cycle of sine and cosine will repeat every 2 pi. Doesn't mean that there aren't some sine values that are present more than once in that 2 pi. Sine can equal 1/2, in 2 different places. Cosine can equal negative root 3 over 2, in 2 different places, 2 different quadrants. But the entire cycle will repeat every 2 pi. The very last thing that you guys are writing down on this page has to do with even and odd trig functions. If you plug in a negative angle for cosine or secant, the values will be the exact same as if it wasn't negative. So cosine of negative pi over 6 is equal to cosine of pi over 6. If you look at your unit circle, that would make sense. Same thing with secant, but with all the other trig functions, sine, cosecant, tangent, cotangent, if you plug in a negative, you get out a negative. We'll come back to this one when we talk more about the graphs of the trig functions and things like that later this chapter, but we're just getting it down now because it does show up, I think, once or twice in homework. Otherwise, as soon as we have this page down, let's practice. And as we do, let me try to give you a couple different ways of memorizing, learning, remembering the unit circle as we go. And one of them is a cheater chart. Oh, that sounds exciting. One of them is a cheater chart that you don't even draw a circle at all for. And then another way is to say, I hate radians. Can I just go to degrees and think of it that way? I guess so. Ready? Evaluate the six trig functions at each real number. Say what? Now let's not do all of them. Let's go ahead and do letter B, just because that's a little different. Let's do letter D. Let's do letter B and letter D. Well, I guess C is good too. We'll do B and D. The 6 trig functions, what are they? I'm gonna write them over here to the side, that way we just have to fill them in like a little baby table. So I'll do sine of t, cosine of t, tangent of t, then cosecant, secant, cotangent. Okay. 5 pi over 4, there are 2 things you need to know. Number 1, where is it, which quadrant? That tells us the signs. And number 2, what ratios does it go with?
Third.
Now, just a few of you are like, I don't like radians. Okay, fine. You know what to do. Take this and say, I need to get rid of the radians, so pi goes on top. No, I need to get rid of what I don't want, right? Cancel out. I want degrees. So some of you could do this and say, hey, 4 goes into 180 45 times. How many 45s? 5 of them. So you could think, okay, 1 45, 2 45s, 3 45s, 4 45s, 5 45s. But it's the same thing as counting pi over 4s. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. Either way you end up at, you're right, 225 degrees, which is in
Quadrant 3.
quadrant 3. That's the placement of 5 pi over 4. Same thing as if you didn't like radians and you went to degrees, 225, 180 plus 45. Now you can think of this 2 different ways. One way is to think, hey, it's over, it's a 45. It's over, or left, which would be a negative. It's left the middle one, root 2 over 2. And it's down the middle one, root 2 over 2. You could think about the x, y. That's one way. You could think about the xy, that's one way. The other way is you could think about the geometric triangle. Oh, hey, it's a 45, 45. So I could just say 1, 1, root 2. You could do it that way too. Either way you look at it, question, what sign? The x. Or, what sign? Oh, those would be negative 1, sorry. Opposite. Negative 1 over hypotenuse. Oh, that's negative root 2 over 2 when you rationalize. What's cosine? Oh, he's also negative root 2 over 2. He's the x. Or adjacent over hypotenuse, which also rationalizes to be the same. What's tangent? Ooh, look at your formulas. Y over x. What's y over x?
1.
1. Oh, what's opposite over adjacent? 1. Either way you look at it. You got tangent. How about cosecant? Okay, here's where it gets a little nasty.
1 over
1 over
negative.
y, which if you did the ratio would be, negative 2 over root 2. And then you'd have to rationalize, which would be negative root 2 over, no, you guys probably can't see that. Negative 2 root 2 all over 2. Which is negative root 2. Because those cancel. Hey, if you like the triangle idea, what's cosecant? Cho. Hypotenuse over opposite. Oh.
Wait.
Yeah.
Never mind.
Cosecant would be cho, hypotenuse over opposite. Oh. But either way you take it, whether you flip this guy and rationalize, or whether you come back up here and do cho and flip it. That's right. Secant. Oh. It's the same thing. Oh, it's the same thing. Negative root 2. Because you would flip the other guy, you would flip the x, but that ends up simplified to be the same. What's cotangent? X over y, which is also 1, or adjacent over opposite, which is also 1. You can use the ratios. You can use the x, y's. Or you can use the triangles. Okay. So then this guy, you got to figure out either, well, 2 things. Where is he? What quadrant? And who does he go with? Either the x, y, or the triangle. All right, where is he? Negative. Where are we going with negative? Okay, so we're going down. Pi over 3. Oh, that's 1/3 of a half circle. That's only going to be, okay, so it's down here somewhere. Not 1/6, not 1/4, but 1/3. Those of you guys that hate radians, no big deal. Multiply by 180 over pi. 3 goes into 180 how many times? 60. It's just a negative 60. That's fine. Anytime it's over 3, it's going to be a 60. How many 60s? There's one of them, so only one 60. If it was 2 pi over 3, it'd be 2 60s. 3 pi over 3, 3 60s. So I have the fourth quadrant. What ratio goes with that? My visual ones, over a little, to the right a little, positive 1/2, down a lot, negative root 3 over 2. That's going to be our x, y. My geometers. It's going to be a 60-30, which is going to be 1, 2, root 3. But which one's negative in the fourth quadrant? Not the x, but the y. All right. Whether you use the triangle or whether you use the ordered pair. You guys, I know what they are. You know what they are? Ready, set, go. Sine, cosine, tangent, cosecant, secant, cotangent. How many can you fill in? I know, not giving you a lot of time, but it's also chapter schedule. Have you thought about looking back at those formulas and the x's and the y's? Or have you thought about looking at the triangle and thinking, SOHCAHTOA, HPrecalc? Both ways work? Which way's better for you? Did you at least get a couple? Sine is the y, or opposite over hypotenuse. Cosine is the x, or adjacent over hypotenuse. Tangent is the y over the x. The over 2's cancel because they both have them. Or opposite over adjacent. Secant says take cos, nope, sine and flip them. Oh, that's negative 2 over root 3. Rationalize. I know, I did it in my head. There he is. Secant says flip the cosine. Cool. Cotangent says flip the tangent. Oh, negative 1 over root 3. Rationalize. Rationalize. I'm going to show you guys the cheater chart tomorrow, not today. So it is an alternative, but I need you to make sure that you have down the idea of either using the triangle or the ordered pairs first, using your notes, not directly out of your mind, out of your brain. But how do you find a trig function? Either using a ratio or a triangle, but you have to figure out where is this value first in your unit circle. We don't need that page. What did we miss? Oh, this is the one example that we need to finish with, I think. Oh yeah, just homework problems. He's not in the unit circle. Unit circle only goes up to 7 pi over 4, so are we done? We are going to keep going. So we have, ready? 1 pi over 4, 2 pi over 4, 3 pi over 4, 3/4 of a calzone, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. Where's 9 pi over 4 back to? 9 pi over 4 is in the exact same placement as pi over 4. So what are we going to use? Either the ratio over, oh, middle, so negative. It's a positive in the first quadrant. Or you could use a 45-45 triangle, but either way, what sign? You can even do trig of coterminal angles. You just have to figure out where does he land. And guys, here's another way of thinking about it. Rate pause. Mixed number, wouldn't he be 2 and a 4 times? Oh, 2 pi and a 4. There it is. All right, cool. Homework 4.2. Do it for tomorrow. Let's see how it goes. We will be working starting tomorrow on making the unit circle go fast. So tonight is how we work on it. Thomas took it late, so I'm going to be grading that. You should get back to his week. I don't know. Oh.
I was meant to see you. Okay, girl, do it. No, I'm taking out of lunch that it grew. Wait.